Section 1.5, solution sets of linear systems. For given linear system AX equals B, if B is 0, then we call it a homogeneous linear system. It has always at least one solution. We can check easily. 0 is a solution of the system. So we call the zero solution the trivial solution. Any non-zero solution is called a non-trivial solution. If right hand side B is non-zero, we call it a non-homogeneous linear system. A homogeneous linear system has a non-trivial solution if and only if the system has at least one free variable, right? Okay, here we'll begin with solutions of homogeneous linear systems. Determine if the following homogeneous system has a non-trivial solution. Then describe the solution set. Okay, to solve this system of equations, we may begin with the augmented metric. So 1, minus 2, and 3, and that is the right side is 0, and minus 2, minus 3, minus 4, again 0, and 2, minus 4, 9, and 0. Okay. Now this is a pivot, and we have to eliminate below the pivot. So first row is same, not changed. But below here, twice added, then there will be 0. Twice added minus 7. Twice added 6 is added to become 2 and 0. And now we subtract twice, then this is 0. Subtract twice, then there will be 0 again. Subtract twice, then remain, this is 0. Okay. Okay. Now, in this echelon form, we have pivots here, here, so that there's no free variable. So from this statement, we can say that this linear system has only the trivial solution because there is no free variable. Of course, over there, now we can make a multiply 1 over 3 to get 1, and we eliminate these values, and now scale to be 1 and twice added to eliminate that one, so that it's the reduced echelon form is here 1 0 0 and 0 0 1 0 and again 0 0 0 1 0, so that here the solution is only the trivial solution. So solution set is just a 0 vector. Okay. If the solutions of AX equals 0 for a homogeneous system can be written in the form here, linear combination of R vectors, and C1 to CR are scalars, and U1 to UR are vectors of the same size as X, then they are said to be in parametric vector form. And once this homogeneous system has a non-trivial solution, then the solution can be written in this parametric vector form. When the solutions of AX equals 0 is in the form here, in this form, then we may say here that the solution set of the system is the span of these vectors. Okay. Okay, solve the system and write the solution in parametric vector form. Okay, so let's try to solve the system. Again, we start with the corresponding augmented matrix. So 1, 2, minus 3, and 2, 1, minus 3, and minus 1, 1, 0. Okay. And here, in augmented matrix, we have 0 column. And if you apply elementary row operations, then this 0 column is not changing, always 0, so that we may ignore and we understand that this portion is matrix itself, and there is another column, 0 column for the right side, but we just simply omit the writing. Okay. Okay, from here now, and this is a pivot, and eliminate below. Twice subtraction will make a 0, twice subtraction minus 3, and twice subtraction will make a 3, and addition will make a 0, and addition will make a 3, and minus 3. Okay, essentially, these two rows are the same, along with the negative 1 multiplication, they are the same, so that by adding, we can eliminate this last row. And then here, we have here now 1, 2, minus 3, and applying scaling, divided by minus 3, we reach at 0, 1, minus 1, and last row is 0 row. Okay. Now, to reach at the reduced rational form, we have to eliminate this one. Twice subtraction will make it 0. This one will become 0. 1, 0. Twice subtraction, 2 is added, so it's a minus 1. And 0, 1, minus 1, and 0, 0, 0. Okay. So from the first one, there's x1. x1, x2 are basic variables, and x3 is a free variable. So x1 minus x3 becomes now here x1 equal x3. And from the second one, now x2 is again x3. x3 is the free variable, that is x3. So we can get the solution x equal x3 is a parameter and vector is 1, 1, 1. Right? So here the solution set is span of this vector. Right? If we write down this as V, then the collection of all solutions of the system can be written here. Now, okay, now span of V. Okay. Okay. Describe all solutions of AX equals 0 in parametric vector form, where A is row equivalent to the matrix. Okay, that is, so that you may consider this as A, but we apply a few row operations and to get this one, but it's not yet in reduced echelon form, so that we have to apply further elementary row operations. Right now, this is pivot, pivot, pivot. So in backward operation here, 6 times added, and that will become 0. Okay. Now, we have to eliminate this one again. We can add 6 times over there to make it 0. Okay, here now, so that the first row will become 1, minus 2, 3, and 6 times added, that will become 0. 6 times added, so that will become 29 and 0. Okay. Now, second row is 0, 0, 0, and 1 and 4, 0, and third row is 0, 0, 0, 0, and 0, 1, 2, 3, 4, 5, okay, and 1, and the last row is 0 row. Okay, so this is reading 1, reading 1, reading 1, except the reading 1, the columns are empty, so it is the reduced echelon form. From this one, now we can get the solution. Here, apparently, right now, x1 and 2, 3, 4, x4 and x6 are basic variables, and then 2, 3, 5 are free variables. So we keep basic variable left hand side and free variable right side. Okay, so from this one we can get now x1 equal, we are moving this term to the right side, so that is 2x2 and minus 3x3, and that is minus 29x5, right? And x2 is free, x3 is free. Now from this one, x4 is same as here, minus 4x5, that is minus 4x5, and x5 is free, and x6 is here, that one, x6 is here 0. Okay, from these equations, and we can find the solution. Okay, x2 must be x2 free variable, x3 must be x3, and x5 must be x5. Okay, so from this one, let's try to write down the solution left side. Okay, so here the solution x is, now for the free variable x2, the vector must be 2, 1, 0, and all the way down 0. Okay, for x3, okay, the direction must be minus 3, 0, 1, minus 3, 0, 1, and then again all the way down 0 values. And finally, for x5, okay, the vector must be minus 29 for the first component in 0, 0, 0, 0, and minus 4 and 1, 0. Right? So that's the general solution. x2, x3, x5 can be arbitrary numbers, and the solution set is a span of these 3 vectors. Okay, and also a single equation can be treated as a simple linear system. Solve the equation of 3 variables and write the solution in parametric form. And to solve this one, again, we start with augmented matrix. So that is now 1, minus 2, 3, and 0. x1 is basic variable. x2 and x3 are free variables. So from here, now x1, we can write down x1 equal 2x2 minus 3x3, and x2 and x3 are free variables. So the x2 is x2 and x3 is x3. So from here, we can get your x, okay, that is x1, x2, x3. That is same as for the parameter x2, the direction is 2, 1, 0. For x3, and the direction must be minus 3, 0, and 1. Right? Okay. So the solution set is plain and including these two vectors. In fact, the span of these two vectors. So it becomes a plane containing these two vectors. Okay. Okay, we'll continue in the second part. Thank you.